Hello and welcome. I am Vishwanath M. In this video, let us try to learn and understand the program 5 of Artificial Intelligence and Machine Learning Laboratory of VTU. The program is titled Artificial Neural Network using Backpropagation. So there are two basic things here. One is Artificial Neural Network, other one is Backpropagation. This program can be better understood if the theory is learnt in advance. Anyway, in this video, let us get a basic introduction of what ANN means, and then we will get into the program. So artificial neural network is a model or an information processing model which is inspired by the natural or the biological neural network. In a way, we are creating a neural network which is similar to how the brain functions. Okay, and every unit is called neuron. So by every unit, I mean in this diagram, we can assume that we can understand that each circle or whatever we have depicted here is a neuron. So this is the input layer, this is the output layer, this is the simplest neural network which is possible. We can have many layers in between, they are called the hidden layers. In this basic example, I have not considered the hidden layer. In any neural network, the basic understanding is like this. To the input layer, the inputs are directed, and the neural networks, the neurons in the neural networks are connected by what is called as link. So these two arrow marks represent the links, and each link will be associated with a weight. Weight is like a significance or the importance you give to that particular input, something like that. We can get a basic idea of what weight and link means. Now this is the formula which we usually find in the theory. So in this neural network, the output, that is the y here, is calculated by multiplying x1 and w1, x2 and w2 and adding them. After that, that is what we have got here before this y. So in this y, all this calculation happens, and the final output y is the f of what we have calculated here. So what is f here? F is an activation function. All this is necessary because what we see here, sigmoid, is basically an activation function. Now, what role does backpropagation play here? Now, as we saw, W and W2 represent the weights. They are the significance or importance values for every neuron or for every link. Now, initially what we do, we assume some value for W and W2 randomly. There is a method of initializing it, which we will see just a little while later. So initially we will have some values for W and W2, and we will calculate Y. And as we know, basically we are training the model. In a way, we are just mimicking the function of the brain. So we will have some value of Y here, that is the correct output, that is the true output, and this will calculate something. So every time we do that, unless the calculated value is equal to the actual value or the true value, we continue the learning. So when I say continue the learning, we understand what is the difference between the correct output and the calculated output, what we call as error, and we backpropagate. We go in the reverse direction. So the movement in the forward direction is called forward propagation, and going behind is backward propagation. Now when we go backward, what is it that we have to change? We cannot obviously change the x values, so we can change w values, that is the weight values. We can change the significance we are assigning to each of the inputs. So in order to change the weights, we have various methods. One method is backpropagation. That is what we are doing in this program. Now we see this name called sigmoid function. So let us just have a basic understanding of what sigmoid function is. Sigmoid function basically gives an S-shaped graph or S-shaped curve, and the basic definition, mathematical definition of sigmoid is 1 by 1 plus e power minus x. Now all this will come in the theory. Let us not get too much into it. One important parameter we can understand is learning rate, which we use in the program as well. Learning rate. So learning rate is like a parameter which will define how fast or how what is the pace at which the neural network is learning. So having got this introduction, let us get into the program. So in order to process the inputs, we need numpy package, numerical Python. So we import it as np. Now before understanding what these values mean, so I have just represented the same in a table here. So this is feature 1 and feature 2, which can be like attributes, and this is the output value. Now this is what I have, this is what we load into the program, or this is what we type in the program here. So x is like the input, so this is the x layer, that is the input layer. So we just feed the we just enter the values 2, 9, and the first corresponding output is 92, 1, 5 corresponding output is 86, 3, 6 corresponding output is 89, and this is the syntax, np.array. If you create an array, so basically x will be a 3 cross 2 array, that is what we are trying to do here, and y will be a 3 cross 1, 3 cross 1, because there is only one column. And after we have given the inputs for x and y, what we do, we just convert, we just in a way we just normalize. So this 92 will be divided by 100, every value in the output column will be divided by 100, and so in a way we are normalizing it. So this will become 0.92, 0.86 and 0.89. And what do we have to do about these values in the feature tables, feature 1 and feature 2? What we do is, this is the convention of this is what a method we have followed in the program. What we are doing here is, we are finding the maximum value in the maximum of x array longitudinally, that is vertically, maximum is 3. So what we do, since we have reduced this to less than 1, in a way we are reducing all these values also to less than 1. So each of the values will be divided by the maximum of these. So 2, 1, 3 maximum is 3. So this will become 2 by 3, this will become 1 by 3, this will become 3 by 3, and maximum of this column is 9. So this will become 1, this will become 5 by 9, this will become 6 by 9, and this will be 0.92, 0.86, 0.89. So just to verify that that is what is happening, so we have seen here. This is as I said, this will become 2 by 3, which is 0.67, and the last just to verify, this will be 3, the maximum is 3, so 3 by 3 is 1, and here the maximum is 9, 9 by 9 is 1, and the output column can be verified here, it will be 0.92, 0.86 and 0.89. So this, we have understood what we are doing in this part of the program. Now sigmoid function and derivative of sigmoid function, it is written here. This is the basic definition, so we are just defining, we are just creating that sigmoid function in our program. So this is the mathematical representation. If you remember this, writing this will be not a major task. So we are just defining a function called sigmoid. It will take a parameter x. This can be anything. So if it takes a matrix, the return type will also be a matrix. If it takes single numerical, it will return single numerical. That is the advantage of Python. We are not defining any type here. So whatever the type of parameter that comes in will be the here, as you can see, we will just return the same type. That is the basic understanding. So we are just defining the function here, 1 by 1 plus np dot exponential of e power minus, that is e power minus x is written as exponential of minus x. Now by differentiating this, it will be a long procedure. Finally we can arrive at this result, x into 1 power minus x. So we have just used the final result, so we are just defining the function here, x into 1 by x. This can actually be verified by deriving this by performing the differentiation, what we do normally in mathematics. We will finally arrive at this result, x into 1 power minus x. After having defined the sigmoid and derivative function, now let us get into the actual stuff, that is the ANN and backpropagation. So it is very important to understand what this diagram says. So in a way, this first layer, this is the input layer, this is the hidden layer, and this third one is the output layer. So if we understand this, we can in a way write the code here. Now epoch is like the number of times the program has to run, or the learning has to take place. So that is a value 5000, which larger it is, the better the learning will be, and learning rate will be usually given, so it is 0.1 as given here. So we can understand from the diagram, in the input layer there are 2 neurons, neuron 1 and neuron 2. In the hidden layer there are 3 neurons. Output layer there is 1 neuron. This is also not something which is prerequisite. We can write this diagram by referring to the table given, that is feature vector and output vector. So this is basically, we have this represented this table in this diagram here. Okay, now you also see some things called WH, BH, BOut, WOut, and we have written some values here. We will just come to it a little later. Okay, now here we are initializing the weight and bias. By weight and bias, I mean by weight and bias I mean so as I said, weight is like a significance we assign to each link. Okay, now each of these links will have a particular weight or a particular significance value. How are we? As I said in the beginning of this video, initially we will just take random numbers. So we are just using this function np.random.uniform. So this will just select a random number from the uniform distribution of the values. But basically this uniform function can take more values inside, there is more parameters inside. Since we have not taken anything, the documentation of numpy we can get this information. Now this np.random.uniform, it will basically select a random number from the uniform distribution of the lower value and the higher value. We have not specified anything here, so it will always be between 0 and 1. So all these values will be 0 and 1. And so then what does this size mean? So size is basically how the WH value should be. So in a way we are just defining that it should be a 2 cross 3 matrix, it should be a 1 cross 3 matrix, 3 cross 1 matrix and 1 cross 1 matrix. Now what is WH? Weight that is going to the hidden layer. Weight is WH is weight going to the hidden layer. So it is 2 cross 3. So from 2 neurons it is going to 3 hidden layer neurons. And what is BH? Okay, now what is BH? BH is base going to the hidden layer. I mean bias going to the hidden layer. Bias in common terms is like a parameter which will define your thinking, which will kind of influence your thinking. The exact meaning of bias in this can be explored by going deep into the artificial neural networks. In a way we can understand this bias is an important parameter which will shift this curve. So this sigmoid curve, so depending on the BH value, this curve can move either left or right. That is the basic meaning of BH. And this BH is what is going to the hidden layer, B out is what is going to the output layer, that is the output neuron. W out, same meaning, going to the output neuron. So these numbers become more meaningful if we remember the diagram, if we understand the diagram. So this is what we are doing here. We can just replace this variables by these values itself directly, which is not a problem. But just to keep it generalized, we are keeping the variable names itself. There is no issue whatsoever if we just write size is equals to 2, 3 here. Okay. Now after having done the basic initializations, we move on to the actual learning, that is the ANN part of it. So as I said, epoch is the number of iterations the program should run, or in a way how many times the entire process should take place. So for I in the range of epoch, so here we have taken it as 5000, that means it will run for 5000 times. And okay, now as I said, initially we will have assumed some values and it will calculate some value of y, and we will actually have the true output. This output will already be given. We are loading it here in the form of this y array. So we are just calculating what this ANN is computing. Okay, so in the first, let us understand the first iteration of the forward propagation. So it will use these values. It will see h input is what is coming here. So what it will do, it will multiply this input values with the weight and it will add bias. So bias is like a value which will be added, not multiplied. That is the important thing we need to remember. In the earlier part of this video, I just said how will this be calculated. So it will multiply the value of input and its weight. So that is what is happening here. Dot product np.dot of x comma wh, and we are adding the bias. Bh is added. So that is h input. And what is h layer act? So h layer act is hidden layer activation. You can you can understand like that. As I said, if this is the value calculated, actual output will be the f of that. So activation function should be called. In the program we have used sigmoid as the activation function. There are many activation functions, actually we are using sigmoid. It is one of the simplest and most preferred also. So we are just calling sigmoid function on whatever is the calculated value. So this is like y calculated, h input refers to y calculated. So f is replaced by sigmoid. So we are just calling the sigmoid function and we are calculating h layer activation. So this is we are completing here, and the same thing will be repeated for this output layer. So here we are using whatever is calculated before H layer act and W out. So these are the weights coming here, plus we are adding the B out value. B out is the bias for the output layer. Again, doing the same thing, we are calling the sigmoid function or the activation function for whatever we have calculated. So forward propagation is clear. This part happens for the first time. It will happen every time actually. We are understanding the first iteration. Now, after having understood this, it would have got some value for output. Okay, now after having got the output, as I said, it won't be proper, it won't be accurate, because we have assumed the values of WH and W out, which is not practically right. We need to learn, the ANN has to learn and it has to update its WH and W out values so that the predicted output will be near to the actual output. So what we will do, now we will create two variables called outgrad and hidden grad. So the basic understanding is very simple. So in the forward propagation we are using the sigmoid function. In the reverse propagation, that is a back propagation, that is what the program is dealing with. So what we do, output grad. So outgrad is like we are going from this output layer neuron to the hidden layer. So we are calling this function derivatives of sigmoid. It is a function which we have defined here. So as I said in the earlier part of the video, it is just the mathematical differentiation of the sigmoid function, nothing else. So in this stage, that is in this stage, we are going from output layer neuron to hidden layer neuron. So the parameter will be the output calculated. Then we are going from hidden, now next we are calculating hidden grad. In a way we are going from hidden layer to input layer. So the same function will be called, but the parameter will be what is calculated here, H layer act. So understanding the program is very useful, because that will in a way guide us how to write the further lines of code. Okay, now as I said, we will measure the error. What is the error at the output? Y is the actual value, that is the actual value which we have given, and output is a value calculated. So this output will be calculated in every iteration of this for loop. So we are calculating the error at the output layer. Then the output, it is like a measure which we are calculating. So in a way we are this outgrad is like calling this derivatives of sigmoid function on output, and it is storing some meaning. We are using whatever this outgrad is, we are using the meaning stored in outgrad. In a way we are just multiplying. So the best way to remember this is, we are finding the error at the output layer, then we are using the error and we are multiplying with the gradient. You can think like that, because in this sigmoid function there is a gradient. So in a way to remember better, we can assume that in a way we are just using the error found in the previous step along with the outgrad. That will be stored as D output. The same thing will be done here in for the previous layer. So this is EH. How do we find EH? So EH is like, we find the dot product of D output. What is D output? D output is what we have calculated in the previous step. That is like we are doing a back propagation. So from here we have come to the hidden layer stage. So at the hidden layer we are using what we have got in the from the output layer, D output, D underscore output, and we are performing dot product with W out dot T. Now we may understand why this T is used. Basic understanding of matrix operation will let us know that T is like the transpose. So we are just performing the dot operation for whatever is coming from this error, that is the output layer. We are multiplying with, we are performing the dot product with the weights, but we are doing the we are performing the dot operation on the transpose, that is the transpose of the matrix. That is quite understandable, because in the forward matrix we are using the values coming from the input layer. In the reverse, that is when we are going from the hidden layer to the input layer, we are using the transpose of the matrix. That is how we can remember. So we are just performing the dot operation of D output and W out dot T, and D hidden layer, as I said, the same thing. That we can understand the program like this. Initially we calculated the error at the output layer, then we calculated the D output measure by just multiplying it, then we calculated the error at the hidden layer in this step, and then we calculate this D hidden layer measure by just multiplying EH with the hidden grad. Hidden grad and out grad are calculated here. They are just the return, whatever is returned by the derivative sigmoid function. Now the program up to this stage is understood. As I said, once this is done, once the backpropagation is done, why did we do backpropagation? The basic purpose is we are updating the WH values and WOut values, because initially we had assumed, now we have understood what is the error. So in a way we are in a better position to assume, not assume, update the values of WH and WOut. That is what we are doing here. WH is the weights at the going into the hidden layer. So obviously it will be whatever is coming, that is x dot t, and we are performing the dot operation with the hidden layer. So we, from the whatever the results from the backpropagation we did here, we are using it. That is what we can understand. Plus the learning rate. Learning rate, as I said, it determines how fast or what is the pace at which the ANN is learning. So we are just performing this, we are just calculating this value and we are updating WH plus equals to, this is nothing but WH plus WH is equals to WH plus this value. So we are just updating the WH value. The same thing applies to WOut as well. WOut as well, when I say WOut, here the value of W going to the output layer. Here obviously we need whatever is calculated up to here, that is H layer activation function dot T. That is what. So when we are going in the forward direction, we are not using the transpose anywhere. So we can understand here we are not using the transpose anywhere. But once we have done backpropagation, we are using the transpose. So H layer dot T, and we are performing the dot operation with the D output. D output is going from here to here. Again, we are multiplying it with the learning rate. So what we have done here, we have updated WH and WOut. So now these will be the updated values of WH and WOut. In the next iteration, the values calculated for H input and ultimately output will be a better value. Better value in the sense the error will be lesser, because the values we are used now, they are not assumptions, they are updations. So this will run for 5000 times, and ultimately we are just printing the input, we are printing the output, whatever we have given in the form of this Y array, and whatever the ANN has predicted. So this is what the ANN has predicted. Since we have run it for 5000 times, we can in a way appreciate the output. It is, if the actual output is 0.92, it is assuming it is predicting 0.89, and when it is 0.86, it is predicting as 0.87, and 0.89 almost 0.895. So in a way we have understood the program, every line of the program. This will help us to in a way memorize. We will be able to know what comes after the previous part of the code. So that was all the intention of this explanation. So after having understood all this, it becomes easier for us to write the program and ultimately execute it. That was all in this video.